So the question on those molecules would be, compounds would be to determine the oxidation number on each element in this substance. And the way to do it is by setting up a very, very simple equation. You always set up your equation, I always like to say, with an equal sign. So you say, here it is, equal sign. And that equal sign is the sum of your oxidation number. So this is the sum of oxidation numbers. So we start by looking, what is this? It's a 0. It's neutral. And then you start with what you know. Do I know about carbon or oxygen? We do know that oxygen is a -2, unless it's an element or peroxide, but that's only in H2O2. So I guarantee you 99% of the time oxygen in the compounds or molecules will be -2. Again, O2 by itself, that's a 0. But in this case, it's not by itself, so this must be a -2. How many of them do we have? Well, we have 2 of them. So we say 2 times -2. So again, that -2 is from oxygen. And we have 2 of them. And if you don't know what carbon is, that's X. It's unknown. So just solve now for X. 2 times -2 is -4. And of course, you're solving for X, so it's going to be a +4. So therefore, X is equal to a +4, and that would be the oxidation number on carbon of C. So we know now that C is a +4, and of course, oxygen is a -2, but we have 2 of them, so that's why it's a 0. Some of you may know and say, why do I have to use this equation? I can just figure it out. Absolutely, that's true. But in some cases, we have to use it because we may have multiple atoms, and it's kind of nice to show our work rather than just get confused with too much information in our head. So SF6, so what is the sum? It's 0, there's nothing here. It's a neutral. How many fluorine atoms? We have 6 of them. We said fluorine is always -2 unless it is an F2, which is an element, but it's not. So -1. So again, F is a -1. And of course we have S, so that's the unknown. S, we don't know what S is. Don't go to the ion sheet and put -2 for S as sulfide. No, that's not the case. This is, again, you have fluorine and it won't actually come out to 0. So you go and you're checking this out. Let's find out how to solve for this. X minus 6, that would be a 0 plus 6 plus 6. X would equal +6, which is the oxidation number on sulfur. So you have sulfur +6, and of course we have F as a -1, but of course we have 6 of them, 6 F atoms, so they come out to be 0. So let's go to the next one. What's the sum? It's 0 also. Start with what you know. We have 3 oxygen atoms. Oxygen is a -2. What are you likely to know more? C, H, or Na? Now, let's go back to some of the rules. That's why we have to practice to remember the rules. It says group 1 metals are always +1. There you go. So Na is known. It's a +1 oxidation number. Let's see if H, there's a hint about H here. Yep, it says oxidation number of H is +1 when bonded to a nonmetal. In this case, C is a nonmetal. Check your periodic table. So Z is unknown. We have 1 on H and of course 1 on Na. So +1, +1. This is X, and of course this is a -2, and we have 3 of them. So solve then for X. So we have 2 plus X minus 6. 2 minus 6 is -4. And of course, +4, and that would make it X equals +4. So that's the oxidation number on C. So therefore, to summarize, we have C is +4. We said O was a -2. Once again, on each individual atom, H is a +1 and Na is a +1. So here's an example of iodate, or iodine. It's a halogen, but it's not attached to something that would give it a -1. It's attached to O. So let's actually go back up to here and look how I can have oxidation numbers of -1 normally, but if they are bonded to oxygen, they can have positive oxidation numbers. So in this case, we have oxygen. So again, you set up your sum of oxidation numbers. What is this? If you can see it, it's a -1. So that's the sum. It's a -1. Then again, you work your way to I. So you have 3 times -2. That's oxygen plus X. We don't know what the oxidation number on iodine is. So X minus 6 equals -1 plus 6 plus 6. That would make it X equals +5. So that's the oxidation number on I. So it's +5, and of course you have. Now again, I'm sure some of you are saying I don't need an equation to do this. I can just figure this out by simply knowing that oxygen each is a -1, so that's a -6. If it's a negative, it means the charge on I must be a +5. Like I said, but here's a very, very nice organized way of doing it. So last, almost there, is that we have dichromate. Once again, we start with the sum of the oxidation numbers. That sum is a -2, right there. -2. And then how many oxygens do we have? We have 7 times -2. But be careful, we have 2x now because we have 2 chromium atoms. Notice the 2 right there. So that's 2x. So it's going to be 2x minus 14. 7 times 2 is 14. Plus 14. Again, I'm going through very, very simple math. This is not calculus. This is Very, very simple math. So 2x equals 12. Again, we want to solve for x, so that's divided by 2, divided by 2. That would give us x equals plus 6. So that's on each chromium atom. And of course, the O is a minus 2. That's the procedure right here. And finally, if you encounter something like this, then you need to actually implement your knowledge of ionic compounds. So that should not be dismissed. So what do I have here? What we have here is we have zinc and nitrite. So if you remember, anytime you have parentheses, what you should be doing is, from what we learned, is the idea of we can separate these into the ions. So what we do is we do the uncrossing. We take the 2 and put it over the zinc, and then of course you have the nitrite with a minus 1. So now here's the oxidation number of zinc. It's an ion. So zinc is taken care of, plus 2. So the oxidation number is plus 2. And now you have to do nitrite by itself. So in this case, it would be 2 oxygens so it's 2 of them. Xn is unknown. So it would be x minus 4 equals negative 1 plus 4 plus 4. That would make it x equals plus 3. So to summarize, zinc is a plus 2, N is a plus 3, and O is a minus 2. So that's what you would like to do with these. Make sure you do enough of these practice in your homework. I advise you to do some practice before you actually begin with the next topic, because you have to know this topic in order for you to do the next topic. It makes sense. So do some practice before you go to the next topic, especially this very last topic.